In this video, we're going to learn how to increase the size of a dynamically allocated 2D array in C using realloc. The first thing we'll do is include stdlib.h so that we can get access to malloc and realloc and free that allow us to work with dynamically allocated memory. Now to dynamically allocate our 2D array, we're going to create a pointer to an int called array. We'll also create variables to keep track of the number of columns and rows in the 2D array. So we'll have int cols is equal to 4 for the number of columns, and int rows is equal to 4 for the number of rows. We're going to allocate space for our 2D array by first allocating space for an array of pointers to ints. This will effectively be an array of pointers to the rows of elements in our 2D array. So this array will need to be of length rows. Then we'll dynamically allocate space for each individual row in the 2D array, where each row will be an array of ints that has a length equal to the number of columns in our 2D array. So first we'll have array is equal to malloc, and we'll have size of int star for the size of a pointer to an int multiplied by the number of rows in our 2D array. So this is effectively going to give us an array of pointers to arrays for each row in the 2D array. Now we have to allocate space for each row. So we're going to have for int I is equal to 0, I is less than rows, I++, to loop through each index in this array of pointers to ints. And each one of these pointers to an int is going to point to a dynamically allocated block of memory that's large enough to store a row of ints in our 2D array. So we're going to have malloc size of int multiplied by the number of columns in our 2D array, because the number of columns in our 2D array is going to be the length of a row in our 2D array. So that's actually it in terms of dynamically allocating the space itself for the 2D array. Next, we could populate it with some values just so we can see what it looks like. So we'll have for int I is equal to 0, I is less than rows, I++ to loop through each row. Then we're going to loop through each column. So we'll have for int j is equal to 0, j is less than the number of columns, j++, and we're going to actually put a value in each element of the array. So we'll have array at index I at index j is equal to, and then we'll have I times 10 plus j, just to put a unique value at each element in the array. So this first loop here, the outer loop, is going to loop through each row. And then for each row, we're going to loop through each column, and we're going to put a unique value at each row and column index. Next, we can print out the array just so we can see what's inside the array. So we'll have for int I is equal to 0, I is less than rows, I++. Then we'll have another loop again for each column. So we'll have for int j is equal to 0, j is less than the number of columns, j++, and we'll print out the value at each row column index. So we'll have %02d space followed by array at index I at index j. After each row, we're going to print out a new line to put the next row on a new line. And then we'll also output one more new line at the end here after we've finished outputting the 2D array itself. I'll just fix this here so that way the printf with the new line happens after each row. So we can save this, compile and run a program, and we can now see that we have successfully allocated space for this 2D array with 4 rows and 4 columns. And we can also see the values in the 2D array as well. Now to increase the size of our 2D array, we could either increase the number of rows in our 2D array or increase the number of columns in our 2D array. Let's first go over how to increase the number of columns. So right here is where we allocate space for each row in our 2D array. And each row is essentially a one-dimensional array of ints that has the length of the number of columns in our 2D array. And array at index I stores a pointer to each one of these arrays of ints. What we could do is loop through that array of pointers to ints and reallocate space for each row such that it can store additional ints. So let's increase calls by 1 to add an additional column to our 2D array. And then we're going to loop through our array of pointers to each row of data. So we'll have for int I is equal to 0, I is less than rows, and the number of rows hasn't changed, so we're going to leave that the same, I++, and then we'll have array at index I is equal to, and now we're going to use realloc. So we're going to say realloc, and we're going to pass as the first argument the existing pointer. So array at index I, and the second argument is going to be the size of the new array. So we're going to have size of int times calls. And we increase calls by 1. So the block of memory will be 1 int larger, and each row can now store an additional int. Let's actually copy and paste this logic that sets the values of each element in the array to something unique, and then prints out the array. So we'll copy this and paste it. And because we increase columns by 1, these loops here that iterate based on the number of columns will just adjust automatically. So we can save, compile, and run the program. And we can see that each row in our 2D array has now been made 1 int larger. We can see the values stored at each row in the new column of the 2D array as well. So that's increasing the size of the 2D array by a single column. The logic to increase the array by additional columns is basically the same. We just have to increase columns by more than 1. So here we could say columns plus equals, let's say 3. We can save, compile, and run the program. And this time, our 2D array has been increased in size by 3 columns, as we can see here. And that's because the logic here is really the same. We're just reallocating space for a larger 1D array each time now. Now, increasing the number of rows in our 2D array is going to involve 2 steps. We're first going to have to use realloc to increase the size of our array of pointers to ints because we now have additional rows. But for those additional rows, we're going to have to allocate space for them for the first time. We're not going to use realloc. We're going to have to use malloc or maybe calloc because we're going to allocate space for the first time for those new rows. So down here, we'll have rows plus plus to increase the number of rows by 1. Then we'll use realloc to allocate space for a larger array of pointers to ints. So we're going to have array is equal to realloc array size of int pointer times rows, where rows has been increased by 1. So this array of pointers to ints has now been increased by 1 in length. That means we can now point to an additional row of data. Now, we don't need to do anything with the existing rows. They all have the same number of columns as before. What we really need to modify now is that last pointer. We need to make it point to a new row of data. So we're going to have array at rows minus 1 because rows is the length of this array of pointers to ints. So rows minus 1 will give us the index of that last element, the new pointer in this array of pointers to ints. And we're going to have it point to a new block of memory that we allocate. That's going to be the size of a row in our array, which is the size of an int multiplied by the number of columns in our 2D array. So this here is going to allocate space for that new row. Then we could follow the same logic as before to fill the 2D array with values and print it out. So we'll copy this and paste it here. And then we'll save, compile, and run our program. And now we can see our 2D array here that now has an additional row of data compared to before. And all we really did was allocate space for a new pointer to an int in that array of pointers to ints. And then we have that new pointer point to a new row of data. Now, what if we wanted to add multiple rows to our 2D array? In that case, we would reallocate space for our array of pointers to ints the same as we do here. We're just going to increase the number of rows. But this time, we would have to allocate space for multiple new rows. So in that case, we could use a loop to help us out. So let's say we want to have 3 new rows. We'll have int new underscore rows is equal to 3. And we're going to increase rows by new rows. So now this realloc here is going to allocate space for that many additional rows in our array of pointers to ints. Then here, we could use a loop that goes through and allocates space for each new row in this 2D array. So we'll have for int I is equal to rows minus new underscore rows, with I is less than rows and I plus plus. So we're incrementing I from rows minus new rows up until the number of rows in this 2D array. And that's because it's really only these new rows at the end of our array of pointers to rows that we have to allocate space for. So we'll change this to array at index I. And then if we save, compile, and run the program, we can see that our 2D array now has 3 additional rows compared to before. So our solution for increasing the size of the 2D array by multiple rows is working correctly. Now, of course, we should free the memory that's been allocated for this 2D array. So down here we could have for int I is equal to 0, I is less than rows, I plus plus, and we're going to free the block of memory that's been allocated for each row in the 2D array. And then down here, we're going to free the block of memory that's been allocated for the array of pointers to ints for our 2D array. And then if we save, compile, and run our program, we'll get the same output as before, only now we're making sure to free all the memory that we allocated so that it can be used again and we don't have a memory leak. So this is how we can increase the size of a dynamically allocated 2D array in C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.